And thanks a lot. And hello, everybody. This is Dirk here. Yeah, so I would like to take a look at AI and IoT, why now and how to. As Devin said, this is not new, right? So we've been doing IoT, we've been doing AI, depending on who you ask, for years or decades. Yeah. If you talk to IoT folks, they will always say like, oh, yeah, of course. I mean, AI is something that's kind of like a part of IoT, and we do predictive maintenance and preventive maintenance and all these kind of things. And if you talk to AI people, they will tell you like, yeah, of course, we can process sensor data, etc., and make use of it. But what we're really now seeing is that these two concepts are more and more to be seen in context, and especially in larger organizations, you will often have a problem that they are to a certain extent siloed. Yeah? So you will have maybe a center of excellence for AI, you will have a center of excellence for IoT, you will have on the operations side people focusing on the one topic or the other. And the question really is, how do you bring all of this together? How do you enable IoT with edge and cloud computing, and then AI with intelligent assets on the edge, and also swarm intelligence in the backend? And what we see here is that really the first step is that you have a lot of deep AI knowledge, experts who can tell you everything about the different algorithms and their use cases, etc. And then on the other hand, we have experts who know everything about certain asset categories. They know everything about manufacturing these assets. They know everything about operating these assets, and bringing these two worlds together is not easy. I have brought with me a couple of examples just to talk about where we are there at the moment. I mean, obviously everybody has been talking about autonomous driving the last couple of years, and it is happening. I think we're still at this point where we have realized, okay, going from 99.5% to 100% is a bigger step than we all had hoped. And yes, there are regulatory hurdles, etc., and everybody's taking a slightly different take on it. How much of this are you rolling out now in the public, and which steps? I've brought with me here one example. Daimler and Bosch rolling out autonomous driving in the public now, for example, for autonomous parking as a first step. This is not so much, I guess, a technical hurdle we're taking here, but really getting this out into the real world. And then obviously the whole discussion around autonomous shuttles, and that's, I think, the first good example for the difference between asset intelligence, making the asset itself more intelligent and enabling autonomous driving, versus managing a swarm or a fleet of assets, for example, a fleet of shuttles, and then solving the problem of matching demand of people who want to use these shuttles to the available shuttles in the backend. So two different types of AIoT. Another example is the smart connected lawn mower, which is obviously an IoT solution, but also becoming more and more intelligent, not only to optimize the way how the lawn is mowed, but for example also to prevent that the mower is not interfering with any wildlife in the green, etc. So that's also a good example. Another example you can see here, a smart connected tightening tool. This is not, the type of tightening tool that you and I would buy in a Walmart or so. This is actually a high-end industrial tightening tools that's used by manufacturing customers who, depending on the type of factory, we have customers who perform 100 million tightening processes per year, and each of them being a mission critical tightening process. So we've made this type of tool not only connected, but also intelligent, that for each tightening process you can basically control torque and angle and have individual tightening programs that are specific to the type of material, type of screw you're using, the coating on the screw, etc. And then, in addition to the asset intelligence to control the individual tightening process, we also have swarm intelligence that basically captures data from all the tools in one fleet of tools in a factory to basically derive knowledge about potential problem areas and automatically make proposals for solving them. I brought another example here with me, which is actually not a Bosch example. It's the Large Hadron Collider at CERN in Geneva, and it's potentially one of the biggest AIoT applications I have come across so far. It's basically controlling a 27-kilometer long particle collider and then deploying 1 million sensors in a collision chamber to basically detect and analyze particle collisions, for example, the Higgs boson. So all of these are different types of AIoT products or solutions. And this is where actually one important differentiation starts that we have learned. You really have to understand what is it that you're building. Is it something that's highly productized? Is it a smart connected product? Or is it actually a once-off solution, some piece of critical infrastructure, like for example, a traffic network operated by a traffic authority, etc., where kind of different KPIs are important. So for products, it's typically about usability and revenue models, whereas for solutions, it's typically more about efficiency and basically making these different types of sensors and products that you're deploying the solution operate as efficiently as possible. So how do you basically build these kind of products and or solutions? We have developed a best practices framework around this with the AIoT user group. It's an open group of AIoT practitioners. And we have learned that you really need to bring these two different worlds together. So you have the agile cloud world, and then you typically have the not so agile, very safety concerned world of building embedded software, hardware, etc., that's deployed on the asset or close to the asset. And that's really the first challenge that you need to overcome. This is where we've developed, as part of this framework, recommendations how to basically bring these two worlds together. We have learned also that you can't use a single answer for a product organization that needs to work this way versus a solution organization. So we're making a differentiation here and have different blueprints developed for this on the organizational level. And we've learned that this is really one of the key challenges that you have to overcome. Starting with the AI perspective, the AI people, it's usually a world on their own. They have their own processes going about, understanding the business problem, understanding the data that they have or can get, preparing the data, creating models, and then deploying them either in the backend or on the asset itself. That's one key challenge that we're currently seeing. So obviously there's DevOps out there, and I'm assuming if you're working for a hip startup in Silicon Valley, this is what you do day and night. If you are working for the IT department of a large manufacturing company that's still struggling to get stuff to the cloud and still is running a lot of things on premise, then you might not be completely there. And now, in addition to these DevOps related challenges. The next thing that's coming is that suddenly, in addition to managing your code and your applications, you also have to manage AI and your AI models in the same way. So ML ops is kicking in. And then you learn that all of this in terms of deployment in an IoT solution is also not only deployment in the cloud, but it's potentially deployment on the asset. Yeah? So suddenly over-the-air updates become a huge deal and need to be integrated in your DevOps cycle. And again, that's a world on its own. Yeah? Not only from a deploying updates to a potentially heterogeneous asset with potentially multiple target platforms, multiple bus systems, etc. But also from a security point of view, from a safety point of view, managing update campaigns and so on. So it's really the challenge to bring all of these things together. And then from a IoT project point of view, as I mentioned, ideally, you really want to run this as agile as possible, but there will be some parts where agile simply does not work. So procurement and sourcing. Yeah, this is something where at least I think nobody has found the silver bullet how to combine agile and sourcing, right? So especially when you have to source complex hardware, yeah, that's involving potential custom manufacturing, potential variants of the software, because you have to support different chipsets for different regions that work on different frequencies and so on. Yeah, you suddenly are living in a world that requires a lot more long-term planning ahead than you would typically have in a pure agile organization, right? The same applies to the safety aspects of this, right? So that's why we have developed some blueprints for how a per se agile product organization works for AIoT, and taking the non-agile aspects of all of this into consideration as well. When you look at this beyond software and beyond the hardware that's running the IoT software and the sensors, you realize that there's also a whole other world. If you look at these quadrants, we have the digital world, the products that you roll out, and the way how you produce it using some of the things that I just outlined. But then you also have the physical world, right? So how do you make sure, let's say, for example, you're building your next generation forklifts, and you want to build additional sensors for location tracking and maybe proximity warning or something like this in your forklift. Then this is not only about everything we discussed up till now, yeah, but this is also about then extending your physical product, making sure that the additional sensors that you're building in, for example, can be connected to the powertrain, can be connected to any communication buses you have already on the physical asset, etc. So this is why these things really have to work hand in hand. And when you come back to the AIoT organizational model that I was talking about earlier on, there's, for example, one important organizational boundary, which we call asset preparation. Yeah, so in the AIoT org model, this is the work stream at the very bottom that has a dotted line between the main organization. And that's basically related to the physical asset design, so your digital product engineering, and also then, of course, to the manufacturing itself, right? So, I mean, not only the need for using more and more advanced manufacturing ways of setting this up, but also suddenly challenges, for example, how do you validate certain intelligent functions of the products that you are building in your manufacturing setup? So in manufacturing, for example, in the past, kind of like the height of quality assurance manufacturing was that you closed the car door, and then there was this person standing next to the car listening to the noise that the closing car door makes. And if it's not a satisfying plop, then you have a quality issue, right? But how do you basically do QA from a manufacturing point of view for all of the intelligence that you're building in, and so on? Yeah. So this is something that's happening, and has successfully happened, but I really think we've seen only the beginning of it. Let me talk a little bit about what Bosch is doing in this space. So Bosch, for those of you who don't know Bosch very well, we are a multinational engineering and manufacturing company in automotive and white goods and energy and building technology, and so on. We have about 400,000 people working in our engineering organizations and also in our factories. And we have, as you saw early on, a lot of products out there already who are applying this, but I still think this is just the beginning of the journey. And in these different areas that need to play together, we have quite a lot of activities. So in terms of products, smart connected products, I was giving you some examples from mobility, industry, energy, building, and residential, and so on. The digital product engineering, this is something that we see, this has been strategic, obviously, already for the last decade, but now with digital twin and all these strategic new initiatives coming in, we really need to further advance this. So we have a holistic PLM initiative here. Then, of course, Factory of the Future, we have dedicated business units. So, for example, our Rexroth unit, that's a multi-billion business supplying components for the Factory of the Future. And then when it comes to AIoT products, we have, for example, our global AI unit. We have an embedded systems unit. We have an industrial engineering unit. We have an IoT unit. We have Sensor Tech, that's a mass manufacturer of microelectronic mechanical sensors, MEMS sensors, and so on. We have another unit that's more specializing on the initial phases of smaller scale custom hardware development, etc. And all of this basically plays together to realize this vision of IoT. And to come to the other question, so we've looked a lot at the how to, so now let's also look at the why now. Obviously, there is no lack of analyst forecasts that promise to you that this is a gazillion-dollar market opportunity. I decided to spare you these type of slides today, but generally speaking, there is so much activity in the space that I think everybody who's involved in there agrees. Yes, this is happening. On the other hand, I think you can also see that this is still very early stages. So we're not living in a back to future world yet, where everything is smart and intelligent and has hoverboard type of capabilities. So we really think this is just the beginning, and this is going to keep us busy for the next 25 years. If you look back the last 25 years, what happened at internet speed, if you combine internet speed with manufacturing speed, which by its nature is orders of magnitude slower than internet speed, and you take the average of this, you can still see that these are yeah, basically much longer lead times as soon as physical products are involved that require physical product design, manufacturing line setup, and so on, than just putting an MVP together in a cloud and be done with it over the weekend. And so this is why we think this is a long game. But as I said, we already see that this is significantly starting to transform many asset-centric industries. And yes, there is a steep learning curve, and that's why what we see, the time really is now to start building up your skills. And yes, you will most likely already have IoT skills, you will most likely have AI skills, you will already have factory of the future skills, but the trick is really to orchestrate all of this, to make this work together, right? And that's what we see is the time to do now. So with this, I hope I was able to share an interesting perspective with you, answer the questions as promised, given at the beginning of the presentation, and we would now have some time for questions from you.